Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In today's lesson, we're going to be continuing to look at the STL, the standard template library algorithms, and in particular, we're going to be looking at some fun operations for making things into heap data structures. So with that said, let's go ahead and get into it and look at the CPP reference website here. So we're going to go ahead and look at the algorithms library. I'm going to go ahead and scroll all the way down to some operations here related to heap. All right, let's go ahead and see what we've got here. All the way down, we've already looked at, well, many of these operations here, sets, merge, and down to heap operations. So we're going to look at a bunch of these today, and the interesting thing is we've actually already on this series, if you've been subscribed and have looked through some of the older videos, looked at a heap-based container data structure, or rather a adapter, giving us a heap property. So we'll talk about that, review that just a little bit for your data structure knowledge, but that was the priority queue here. So with that said, our main operation that we want to look at is this make heap operation. So let's go ahead and take a look at it. And basically what it does is it takes some container by using two iterators, or if we go back here, there appears that there will be a range-based implementation of this. It looks like there is one and should be in most C++20 compilers. But basically we just pop in a container here with the first and the last element with two iterators here, creating that range, and we enforce some heap property. Now by default here, it says the heap property is respective of the operator with the less than sign. We're just going to play with integers for this particular video. You can check out a lot of my other videos in which I add a comparator. Maybe we'll see. Maybe if we get to the end here, if there's enough time. Well, in fact, actually, we will do it. We will just do a custom comparator because I think it's nice to do. But basically, this is your heap property to be able to see if something is less than the other. Okay, so a little bit of a review here for a data structure here. Let's go to the drawing board here. And what do I mean by heap property? Well, the classic example here is if I've got my airlines here, I've got my first class passengers, my second class, third class, and so on. Okay, fourth class. Or you can think about these as folks lining up at a grocery store. Now, with the heap property, we would say that this person here has the highest priority. Okay, so however you want to establish this. Again, it depends on our operator here. So that could be the maximum value or something representative of that, first class here. Okay, so just to make this example just a little bit more understandable, but this is sort of a real world example. Again, if you're boarding an airplane, here's my very quickly drawn airplane with some wings, right? We think about things in first class, but let's go ahead and just use another example where I give people priority based off of how much money they pay for a package here to ship it first class. So maybe somebody spends $40 US, quite expensive, versus a package that costs 20 versus one that costs 10. And then maybe there's like a standard $5 shipping or whatever. So what you would do is you'd take all of these packages here, and I'll just go ahead and let's just put dots in these ones, 2 dots here, I don't know, 3 dots to represent these, and maybe there's a package here with 4 dots here. So if I was going to just take all of these packages here in the post office and arrange them in some sort of way here, I would form some sort of tree here with, say, this first package, and then the next package to take here. Now, actually, I would probably put this maybe over here, because usually you have the greater things on the left side of the tree. But the point is that everything, your top priority package is at the very top here. And then I would have my other packages somewhere down here. Okay, so let's just go ahead and draw this here. And let's see, I have 2 of these packages here, and then a final package here as well. 1, 2, 3. Oh, I guess I should have 4 here. There we go. Anyway, that's the idea. And this heap property is that everything on this level is greater than or equal to priority on this level here. Okay, that's a heap data structure. And we could represent this as a flat array here. Okay, in a binary tree, meaning that this first level here is representing this guy here, and then the next 2 are represented here, and then the children of these 2 are, well, following from this branch and then the next 2 children, and so on. So that's just a really quick overview of heaps, the sort of data structure that we are working with. Now, the important property is with our heap here, is if I take this or pop this off of the heap, we will maintain this property and the next highest package will eventually get promoted. Now, how that happens, again, we'll have to have a separate data structure video on that, but you effectively take your leaf, rotate it up, and then you compare it with everything else in the tree to make sure that you sort of promote up the next priority package here. Anyway, so that's a quick heap review. Heap review of the heap property. And again, this depends on if we have a max heap or a min heap, meaning does the highest priority or the lowest priority thing go on top. Just depends on your system. We'll write a little comparator to handle that otherwise. Okay, now with that said, let's go ahead and play around with this just a little bit here. And again, I wanted to show you something because we have, let's actually show you here first in CPP reference, right? We have a container adapter for this, right? If we know ahead of time that, yeah, our data structure is just going to be a priority queue, maintain this property, etc., etc. Okay, so we've taken a look at this. And fundamentally, this priority queue container, which again, you can look on the playlist of this series to find my priority queue video, but it basically says, okay, we could use a vector or let's see, a queue here. And I imagine you could probably, I guess it says vector and a deck here because we're modifying them. You can use either of these data structures here. And if you know that you want to enforce this interface, right, where you could just push and pop elements from the top of the heap, then this is great. But again, if you're trying to construct this, right, you just have some data structure that has a ability to grab a iterator to the first element and then or wherever in your range here, you can construct a heap from it. Okay, so that could be a vector, that could be a deck, maybe it's some other data structure that you invent otherwise. Okay, so anyways, with that said, let's go ahead and take a look here now that we've made that connection. And the last thing I do want to show you is I had to dig around a little bit, but if you look in the actual spec here, priority queue is actually implemented right with this make heap operation here. So that's just something you can look at if you want to, dig around. And it's why we have in the standard template library these building blocks, these algorithmic building blocks. Again, just kind of a neat thing to see these tools used. All right, anyways, let's go ahead and write some code. And let's start off with, we're just going to use a vector. Maybe we'll write our own data structure in a bit here. Maybe we'll use one of those examples with the packages so it makes sense. And I'm going to go ahead and create a vector. I'm going to use the C++ class type argument deduction here so that it'll just figure out that we have integers here. So I don't need to specify the type, kind of nice here. And then let's just go ahead and let's write a function here that just goes ahead and prints out the actual vector. So again, we've done this many times here. Print vector or print int vector, what do we want to do? Or call it, and that's going to be a vector of integers. We should do this by reference and const so that it's efficient. And then we're just going to write a range-based for loop here that's going to, again, since this is integers, we could probably just use auto for the element to infer what it's going to be. Don't need to do anything with reference there. And we'll just print things off here. So let's just print off the element and a comma. And we'll just write it out here. Okay, so let's just go ahead and print out our vector and compile this with C++20. And let's go ahead and just make sure that that's working. Oops, I need to do one hyphen here. There we go. And we'll run this program. There we go. Okay, so our vector is printing out. And observe that if I was just going to draw this as a tree here, again, let's move over in our diagram. Right, my data structure is laid out with 1, 3, 8, 2, 9. Remember that in a vector, for instance, that the memory is contiguous here. Okay, so if I was drawing a tree, this would be the first thing, or a heap. Then I would have a 3 and then an 8. These are my leaves of 1. Okay, so I'd have here and here. Oops. Hey, let's get rid of that. No updates. Acting like Windows there. And then let's see, we'd have the leaves of 3 here would be 2 and 9. And if I look at this here, well, do I have a heap property? Okay, potentially I have a min heap here. 1 is less than 3 and 8, so that's true. But 3 is not less than 2 and 9. Okay, so this is not a heap here. Okay, so let's actually call our make heap operation here. And it's from standard make heap. And we're going to have to include algorithm. Again, just to show here, there it is, algorithm. And pass into iterators here, which we'll just use v-begin and v-end here. Okay, so let's include algorithm. And let's go ahead and do v-begin. That's where we're going to start our computation, and we want to go to the end here. I want to make the whole thing a heap. Okay, and then let's print it off here. Oops, got to recompile, and we'll just rerun. And now we get 93821 here. Okay, so again, same experiment here. I'll draw it in a different color for you. But I've got now laid out in memory 9, 3, 8, 2, and 1. 9, 3, 8, 2, and 1. Again, here is our root, the first element, the leaves of 9, and then the leaves of 3 are over here. And the question that we can ask ourselves, oops, sorry, that was a sloppily drawn tree here. Let's make it a little bit nicer. Here we go. 2, 1, there we are. Just going a little bit fast there. But you can ask yourself, is 9 greater than the 2 elements below? It is. Is 3 greater than the 2 elements, greater than or equal to the 2 elements below? And it is. 2 and 1. Okay, so we've got a proper heap here. And you can see that it has modified this actual vector v here, okay, because that's what we're printing out here. So this itself has a few interesting properties for us, because now we've got effectively a priority queue. Okay, so what I can do now is say for, let's just go ahead and say int I, or let's do this a little bit properly, size t, the index equals 0, while the index is less than the how should we do this? So we could say, let's look at some of the vector functions here. Let's open this up. I think it has an empty. Yeah, checks whether the container is empty. And what we want to go ahead and do here is we'll say while it's not empty, actually we can just do this as a while loop here. Let's just do this. While the vector is not empty, let's just go ahead and pop off the elements here. Okay. Okay, so how do I do this? Let's see what operations we have. We've got a pop heap here. And does pop heap return? Let's go ahead and open that up here. Pop heap does not. So how do we get an element here? Well, we've got to store it somewhere. So auto element equals vector. And for our vector, we do have a front operation. Okay. And then I'm just going to do pop heap from our beginning and our end here. Okay. And then let's go ahead and just print off whatever the element is here. Oops. And do a new line. And let's work with this here. Okay. So I should be able to compile this and whoa, okay, what's going on here? Well, let's try to understand what pop heap is doing. Oops, let's go ahead and terminate this. There we go. We're just getting 98989898. Okay, so what's going on here? What is pop heap actually doing? Because we'd expect it to just sort of pop off an element here. Okay, so we're reading the front element. That seems good to me. Let's also make sure we didn't mess up the vector empty. Let's see. So text of the container has no elements, whether begin equals end here. So it's true if the container is empty. Okay, so while not false, so it's false otherwise because it's not empty. So that seems okay. Our condition's okay, but let's investigate what pop heap is doing here. And okay, what's pop heap do? It swaps the value of the first and the value in the position in the last -1. It makes the subrange first to last -1 into the heap. Okay, so this has the effect of removing the first element from our heap. Okay, so did that actually remove anything from our heap? Doesn't look like it. Okay, it looks like it's just doing a sort of swap. So this is a very fast operation. I mean, let's go ahead and here, let's slow this down a little bit. Let's get rid of the loop here. And what I'm gonna do here, let's get rid of our printout. Let's just print out the vector after we do pop heap here. Okay. So here we go. Here it is. And we could see that 9, which was originally, actually, let's do this twice here. Let's print out our vector. So here's our original after we make the heap, and then it just does a swap here. Okay. So if I actually want to get rid of this element here, what I need to do here is actually modify the container. Okay. So in this way, these building blocks here, like make heap and pop heap, aren't really doing anything. So we want to do something like v pop back on the actual vector operation here. Okay. And then we get 8, 3, 1, 2 here. Okay, so that's how this is working. So let's go ahead and put back in our loop here. Pop our heap with each of the elements here. And we'll print them off. Let's see if this works here. And we get 9, 8, 3, 2, 1 here. Okay. Now, interestingly, when we're popping our heap here, we are getting things in order here, which is kind of neat. 9, 8, 2, 1 here. I mean, let's extend our example. Let's put in 7 and 6, 11, -7, 42. And let's go ahead and increase our example. So interestingly, when we do this, because we're maintaining a heap property here, again, this is sort of back to your data structures and algorithms basics here. We're always having the maximum element, if we have a max heap, which is the default here, being popped off. So in this way, we can get our data sorted here. Okay, and there's actually, if we take a look here, I believe a way to sort our heap here. Let's actually go back and just do sort heap. So it turns a max heap into a range of elements sorted in ascending orders here. Okay, so that's kind of cool here. Let's see what this does here. Yeah, we just make the heap and then sort the heap. I guess it's just going to, it's doing it in ascending order, which is interesting. I guess there is a comparator that we can do. Okay, so anyways, let's just make the heap and then here, sort heap, the begin, the end. Okay, and then you should see that we have in ascending order this time here, our heap here. Okay, so that's kind of neat. Now, interestingly though, when I sort the heap here, okay, so at this point here after making it, because I get it in ascending order, when I pop the heap, it's taking off the first element, but it's still maintaining that heap property of the being a max heap here. So I think we want to switch this around, this sort here. Let's sort it so that it's descending. I think it takes in a comparator here. I want to pass in like less, I think. Let's see if I can just do that here. I forget what it exactly is. Let's see, standard or maybe greater. Let's see, I'm going to have to search that here. Let's see here. Greater, I think, let's see. I think it's just greater and then empty arguments. Maybe parens. Let's just play around with it for a little bit. Here we are. I think it just looks like this here. All right. And what does that give us here? Well, let's sort of see this step by step here. Let's see if we can play around with this and get it to do the right thing here. So we'll print out our original vector, and then maybe that's not doing the right ascending thing, but here's our original vector. Here's where we make the heap, which looks good. Maybe actually, let's play around with this because I wanted to do some custom comparator here. So let's just play a little bit here. Standard less, I think, is the object here. Let's see, did that make it a, here's the original. We make it a heap here. Oh, no, that didn't change or appear to do the right thing here. Okay, interesting here. We'll have to play with that a little bit here. Yeah, interesting. It gives us the ascending heap. So sort heap is kind of messing things up. What I want is just a heap sort where I basically reverse things. Oh no, I guess actually let me take that back here. Since it's giving us a max heap, I guess it's doing the right thing here. Sort heap takes a max heap into a range of elements, sort it. Okay, so it's got to take a max heap. I see. Okay. Okay, so it makes sense that that was what was messing it up here. Okay. Anyways, I'm gonna get rid of sort heap for now. And let's go ahead and pass in some custom object here, okay, just to make things a little bit more interesting. So let's give ourselves, I don't know, a package. It's going to have a priority and, you know, a name of the package or whatever. And I want to sort this somehow. Okay, so what's the comparator that I need for this? When I make heap for the comparator, it's with respect to the operator less than. So let's go ahead and implement that. And we'll go ahead and do operator less than. And usually this is something, let's see if they give it to us in CPP reference here. Okay, that's just a comparison. Signature of the comparison function, okay. So again, what would we do without CPP reference? We'd be in trouble. I was going to implement the less than operator here. But that's not so bad. Okay, so let's go ahead and do that here. And the type is going to be package. And package. And we're just going to compare the priority. So we'll return A's priority if it's less than B's priority. Okay. Okay, so let's go ahead. Oh, I see. Yeah. So this is the test that we want to pass here. Let's go ahead and create another vector here. Let's go ahead and do it in the same example. I'll call this packages, and we're just going to construct, well, I don't know, a few packages with a priority of 3 on a string of, I don't know, Mike or something. And let's do this a couple times. 7, Mike 2, and another curly braces. Let's see if we can repeat this pattern a few times here. And effectively just give some random values here. There we go. So let's see if we've done that much correct. Oops, not quite here. What did we make a mistake on? This should be okay. We probably need string. Getting used to using languages that have string built in here. And let's see here. Let's see. Can't infer probably the type. So let's just go ahead and put that in explicitly. There we go. Okay, that's better. And I'm going to go ahead and comment this stuff out for the purpose of this video. We might have to write our own custom print function here for the packages. So print vector of packages. And we're just going to recycle some of this stuff here. And for each of the elements, we're just going to print out their priority. And let's go ahead and print out another comma for who they, or a dash for who they're to. Element name. Make sure that compiles. So far, so good. There's the code. All right. And this appears to be working here. Here, let's give ourselves a few more values here just to make it a little bit more interesting. And again, I've got this custom type here. It is a vector, so again, I could use this as a priority queue, but maybe I need to have this as some other, you know, data structure that I'm going to write on my own, and then I'm going to write my own random iterator, because that's the only requirement for the make heap. Again, if I go back to CPP reference, right, I just need the random iterator, right? And we've looked at, again, you can search in my series how to implement iterators on my software design side. But let's go ahead and just turn this into a heap here. And this is the packages dot begin and packages dot end. And let's go ahead and print out our vector of packages before it's a heap and after. And let's see what happens here. Oh, we get a giant mess of things here. Here, let's see if we can get this far here with printing our packages. We can. Let's clean that up a little bit here. Let's not... yeah, that's an okay output, I guess. 3, 7, 9, 5. Yeah, Mike, 2, etc. Oh, I see. Let's get rid of these. Mike, Bob, Sue, Naomi, Jake, and Maria. There we go. Just so we can see the numbers. Okay. All right. Now let's see how our heap is doing here. If I try to make a heap. Okay, and this is where it's complaining here. Okay, what does it want here? If I scroll up here, and this is good that we always go the extra mile here. I'm trying to figure out how to do the custom comparator. That's probably what it's complaining about here. Blah, blah, blah. Let's see here. I think it just needs the function passed in. That's probably the issue. Yeah, maybe I just needed to do the... This is a free function here. And then I could just pass in compare. See if that does the trick here. That does the trick. All right, perfect. Easy, easy. Okay. Now I could implement this as a member function that just takes in the one package and then returns true or false. That's effectively the same thing, but yeah, let's just do it as a free function. I like to free the functions as well, especially if I'm just working with the public data, which is the priority here. So anyways, let's see, let's print out now and see, did we end up with a priority queue here? Okay. Make this a little bit bigger here. All right. And I've got, well, the highest priority 10 and 7. 9, 5, 3. Okay, yeah, no, this still works because again, it's not going to be sorted necessarily, but I am going to sort the heap next. That's our next task because we'll see it in ascending. But this is greater than the 2 that follow, and then both of these are greater than the 2 that follow, and then both of these are greater than or equal to the other values that follow. Okay, so this holds here. Okay, let's use that sort heap one more time here. I'm just going to change this to sort heap, and let's print out the vector of packages, and we should see these next in ascending order here. So 3, 3, 5, 7, 9, 10 here. Okay, so that took our max heap and effectively sorted it. Now, how it's sorting it, again, you're basically just peeling off the bottom elements, right? Maria, then Mike, then Naomi, and then you're looking at your parents and peeling off the next lowest value, and the next lowest value, and so on. Okay, so not too bad. So let's do a brief code review here, just so I know that's a lot here. But again, these are nice building blocks. So now you have a very flexible way to create a priority queue out of anything. So the last thing that we did here is create our own custom structure here. We wrote a comparison function because there's multiple fields, and we just determined how we did that, right? Maybe with priority, maybe with some other tiebreaker or whatever. We wrote a little function to print everything out. And then for our heap, or rather, we needed some data structure that has a random iterator available, which a vector does, or a deck, for instance. So random access or your own custom data structure. As long as you've got a way to return a random iterator, then you are good to go. And then we were able to print this out, which was the first listing on the top here. I'll highlight it in this row here. And then we actually made our heap, which enforced the heap property. And again, we see those top values. Or the greatest value is first, okay? And then on the next level, these 2 values are greater than any of its children, okay? Enforcing that heap property for a max heap. Okay, so kind of a fun one to work with. Again, you can kind of review your data structures a little bit with this, make heap, but not too bad to use overall. So there you have it. And of course, we also had another example If I go down here of just using integers, which follows a little bit closer to the CPP reference one, but I thought this one would be nice to see as well. All right, folks. So anyways, with that said, as always, these lessons can be found on my website, course.mshot.io. If you want to go ahead and track your progress, you can check out some of the other courses as well if you're interested. And hopefully that's another nice building block for you to add to your collection of STL algorithms. Again, you could probably implement your own heapify operation, if you will, but it's nice to have something that is working and gives you a heap. This is often a data structure, especially if you need to, for instance, sort something. That's very nice, right? We looked at an example of how to actually do that, right? By just popping off elements. Let's actually go back here. By basically just looping through our vector and popping off those elements, right? We could have made a copy of this if we wanted to preserve that vector, but this is an easy way to have a heap sort, which is an n log n operation. So that might work for your data. So anyways, folks, with that said, hope you enjoyed this lesson on heaps, gave you a little bit of a data structure review as well. And let me know if you have any questions or comments below. And otherwise, thank you for your time and attention. I'll look forward to seeing you in the next one.